Have you ever gazed at the night sky and wondered about the life of those twinkling stars? The cosmos, an infinite expanse of mysteries and wonders, has been a source of intrigue for centuries. Among its countless marvels, one stands out as particularly captivating: the life cycle of stars. These celestial giants, with their radiant glow and fiery existence, have a fascinating tale to tell, a tale of birth, maturity, and eventual demise. Well, today we're going to dive deep into the life cycle of these celestial giants. Every star, no matter how big or small, begins life in the same way. Imagine the vast cosmic ocean of space, brimming with mystery. Littered across this infinite expanse are clouds of dust and gas known as nebulae. Nebulae are the true cradles of the cosmos, the birthplaces of stars. They are vast, often spanning light years across, and incredibly dense, filled with the raw materials needed to create a star. Now, within these nebulae, something fascinating happens. Certain regions, perhaps due to a passing shockwave or the pull of nearby stars, become denser than their surroundings. These dense pockets start to collapse under their own gravity, pulling in more and more dust and gas from the surrounding nebula. This gravitational pull creates a swirling mass, much like water spiraling down a drain. As this mass continues to collapse, the pressure and temperature at its core begin to rise. This is the birth of a protostar, the first step in a star's life cycle. The protostar continues to grow, feeding on the dust and gas from the nebula. The heat and pressure at its core gradually increase, and the swirling mass takes on a spherical shape. Now, here's where the magic happens. When the core temperature of the protostar reaches a staggering 10 million degrees, nuclear fusion begins. Hydrogen atoms at the core start to combine to form helium, releasing an immense amount of energy in the process. This energy pushes outwards, counteracting the inward pull of gravity, and stabilizes the star. Suddenly, the protostar begins to shine brightly, radiating energy into the cosmos. The remaining dust and gas are blown away by the intense radiation, revealing a newborn star. This star will continue to shine for millions or even billions of years, depending on its size, fueling its light with the nuclear fusion occurring at its core. And thus, a star is born. But this is just the beginning of its journey. After formation, the star enters a period of stability known as the main sequence. This phase in a star's life is like its adulthood. It's a time of equilibrium, where the inward pull of gravity is perfectly balanced by the outward push of pressure from nuclear reactions at the star's core. The main sequence is where the magic happens. It's where stars spend the majority of their lives, burning brightly in the night sky, and it's all thanks to a process called nuclear fusion. Nuclear fusion is the heart of a star, the engine that drives its luminosity. But what exactly is it? Imagine a dance, a cosmic ballet, where particles of hydrogen come together under immense pressure and temperature, merging to form helium. This is nuclear fusion. It's a delicate balance, a dance that requires precision and immense energy. But the payoff is enormous. When hydrogen atoms fuse to form helium, they release a tremendous amount of energy. This energy radiates outwards in the form of light and heat, causing the star to shine brightly. This is the light we see when we gaze up at the night sky, the light that has journeyed across vast cosmic distances to reach our eyes. A star's size, color, and temperature during the main sequence are all determined by its mass. Larger stars burn hotter and brighter but have shorter lifetimes, while smaller stars burn cooler and dimmer but can continue to shine for billions of years. So the main sequence is a period of stability, a time when a star shines brightest. But it's also a ticking clock. With each moment of fusion, each dance of hydrogen atoms, the star is using up its fuel, and once the hydrogen in a star's core is exhausted, the star leaves the main sequence. While this period of stability can last billions of years, it doesn't last forever. As a star exhausts its nuclear fuel, the end of its life is imminent. This is the juncture where our star begins its transformation, undergoing changes that will ultimately seal its fate. Imagine our star, once a beacon of light and warmth, now swelling into a colossal entity. This is the phase where it becomes a red giant or a supergiant. The star, once a compact ball of hydrogen and helium, now expands due to the pressure from the fusion of hydrogen in its core. This expansion is not just a slight growth, but an explosion of size that can engulf nearby planets. Now let's dive a little deeper into the star. The core, which was once the heart of the star, burning bright and hot, is now a simmering cauldron of heavier elements. Hydrogen fusion, which once ruled the core, is now replaced by the fusion of helium. This helium fusion gives rise to even heavier elements such as carbon and oxygen. These elements are produced through a process called helium burning, a series of nuclear reactions that create the atomic nuclei of carbon and oxygen. As the star continues to burn helium, it creates an onion-like structure with layers of different elements burning at different rates. The outermost layer is still hydrogen, followed by a shell of helium, then a layer of carbon, and so on. This process continues until the star has a core composed primarily of iron. Iron, unlike lighter elements, cannot release energy through fusion. The star's core, once a furnace of nuclear reactions, now becomes a dormant block of iron. This is the point of no return for the star. It has exhausted its nuclear fuel and can no longer sustain its own weight. It's at this moment that the star's fate is sealed. But here's the twist. The manner in which a star meets its end is not uniform, it varies. And this variation is primarily dependent on one factor, the star's mass. The star's fate is now sealed, but the manner of its demise depends on its mass. A fascinating cosmic tale of birth, life, and inevitable demise, isn't it? The death of a star can be a violent event, giving birth to some of the most stunning phenomena in the cosmos. Imagine, if you will, a star, much like our own sun, nearing the end of its life. Its core collapses under the weight of its own gravity, causing the outer layers to explode outward in a brilliant flash of light. This spectacular explosion, known as a supernova, can outshine an entire galaxy for a brief period of time. Now, what happens to the remnants of these larger stars post-supernova is truly fascinating. If the core that's left behind is massive enough, it continues to collapse under its own gravity, forming a neutron star. These celestial bodies are incredibly dense, with a teaspoon of neutron star material weighing as much as a mountain. However, if the core is even more massive, it collapses to such an extent that it forms a black hole, an entity so dense and powerful that not even light can escape its gravitational pull. These black holes become cosmic vacuum cleaners, swallowing everything that comes too close. For smaller stars, like our Sun, the end is less violent but no less beautiful. As they exhaust their nuclear fuel, they shed their outer layers, creating a cloud of gas and dust known as a planetary nebula. This nebula, illuminated by the star's dying ember, paints a breathtaking picture against the dark canvas of space. At the heart of the nebula, the star's core remains as a white dwarf. This dense, hot core is all that's left of the star, slowly cooling and fading over billions of years. So, whether it's the brilliant supernova, the dense neutron star, the insatiable black hole, the ethereal planetary nebula, or the fading white dwarf, each stage of a star's demise brings with it its own unique beauty. In the grand cosmic ballet, stars shine bright, fade, and die, only to give birth to new stars, continuing the cycle of stellar life and death. This is the magnificent and awe-inspiring spectacle of stellar demise. In death, a star can create some of the most beautiful sights in the universe. The life cycle of a star doesn't end with its death. It's a concept that's as fascinating as it is complex. You see, when a star dies, it doesn't just fade into oblivion. Instead, it leaves behind a rich tapestry of elements, a cosmic concoction that becomes the seed for the birth of new stars and planets. Imagine a phoenix rising from the ashes, reborn anew. Similarly, the remnants of a star serve as the building blocks for the genesis of new celestial bodies. The heavier elements, such as iron and nickel, form the core of future planets, while lighter elements like hydrogen and helium coalesce to birth new stars. This is the beauty of the cosmos. a continuous cycle of creation and destruction, a dance choreographed by the laws of physics and chemistry. Every star we see twinkling in the night sky, each planet in our solar system, even the very atoms that make up our bodies, were once part of a star that exploded in a spectacular supernova. We are, in essence, stardust. It's a humbling thought, isn't it? This intricate, never-ending cycle is a testament to the enduring nature of the universe. Stars are born, they live, they die, and from their remains, new stars are born. It's a cosmic carousel that has been spinning for billions of years and will continue to do so for billions more. Thus, in the grand theater of the cosmos, the cycle of life, death, and rebirth continues.